Hi, welcome to RAR Math. Today I'm doing a series of videos on composition of functions. In this video, we have two functions, f of x equals 7x minus 3 and g of x equals 5x plus 1. We're going to do a few calculations and then we're going to play with them. There's more than just these four problems in this video. Okay, so f of g of x is the same of f of g of x. What this means is we're going to take the g of x function, 5x plus 1, and we're going to make it the input of x. In other words, we're going to take f of something equals 7 times something minus 3. That's how function notation works, is the input mirrors what happens on the other side of the equal sign. So in this case, we have 5x plus 1 and 5x plus 1. That's what g of x is, and g of x is what we're putting into f of x. So f of g of x equals, we're going to distribute 35x plus 7, and we are going to make sure to distribute to both numbers in that parenthesis, minus 3. So f of g of x equals 35x plus 4. Okay, going the other way, this is g of f of x. That means we're putting 7x minus 3 into g of x. So we're going to have 5 times 7x minus 3 plus 1. So g of f of x equals, again, we're going to distribute 35x minus 15 plus 1. G of f of x equals 35x minus 14. The fun thing about composition of functions is you don't have to take two functions. I can find f of x. So we're putting 7x minus 3 into 7x minus 3. So we have 7 times 7x minus 3 minus 3. Distribute 49x minus 21 minus 3. So f of x equals 49x minus 24. This right here is maybe the biggest mistakes I see students make. Usually the 7 minus 3 becomes 4, and even the negative 14 plus 1 will become negative 14 instead of negative 16. But the two negatives next to each other, both, being added to negative 24. But this one is a big mistake often too. That leading negative 15 plus 1, negative 21 minus 3, that leading negative is just a killer. You got to be really careful with it. All right. G of x. I'm going to do this one slowly like the first one in case I've been going too fast. I sometimes talk fast. So this is g of something equals 5 times something plus 1. We're putting itself in, so we have the 5x plus 1 and the 5x plus 1. Distribute 25x plus 5 plus 1. G of x is 25x plus 6. Okay. So that's the basics of composition of functions. But let me do a little bit of the proof that everything works. I want to rewrite this down here. F of x equals 7x minus 3. I might have to write more. G of x equals 5x plus 1. See if I need to write more. Probably not, because we'll go to probably there. That should work. All right, it says find f of g of 5 and g of f of 5 in two different ways. All right, so what does in two different ways mean? Well, first way is the way that a lot of students like to do it because they don't always trust their math. So I'm going to find f of 5. F of 5 is 7 times 5 minus 3, which is 35, minus 3, which is 32. And then I'm going to find g of 5. G of 5 is 5 times 5 plus 1, which is 26. 25 plus 1 is 26. So f of g of 5 is f of g of 5. Well, g of 5 is 26, so this is f of 26. And f of 26 is 7 times 26 minus 3. These numbers are getting big, which is 182 minus 3, which is 179. G of f of 5. G of f of 5 is g of f of 5. Well, f of 5 is 32. So g of 32 is 5 times 32 plus 1, which is 160 plus 1, which is 161. But that's only one way to do it. So the other way, f of g of 5 is, we figured out up here that f of g of 5 is 35x plus 4. So 35x plus 4. Well, 35 times 5 is 175, and 175 plus 4 is 179. These are the same. And that was a lot faster than all of this. So if we trust our math, that was a lot faster. And g of f of 5, well, now we have to go find that. This right here is 35x minus 14. 35x minus 14, 35x minus 14, 35x minus 14. Well, 35 times x is still 175, minus 14 is 161, and these are also the same. So 2 ways. One is you can find the individual pieces and do 3 calculations and 3 calculations, and you can get there. The other is to trust your math above and get there directly. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you in the next video. Thanks.